What's up everybody, Adele here. In today's video, we're gonna walk you through how to build AI agents with the Google ADK package. Our instructor Vaibhav will walk you through the fundamentals of building AI agents with Google ADK, how to set it up on your own environment, and building more complex agents that require tools, functions, and more. If you enjoyed this video, make sure to check out our course on building AI agents with Google ADK. And with that said, happy learning.
Hey guys, what's up? In this tutorial, we're going to be learning all about Google ADK, the brand new agentic development kit by Google. Now, this is the best time to get started because, well, it's brand new, and this will really get us ahead of the curve. If you are ready to go on this journey with me and learn about Google ADK, I will see you in the tutorial. Alright guys, so we have a bunch of stuff to cover in this 1 hour to 1.5 hour tutorial. So let's get started with just the introduction. I want to start off by asking you, what even is Google ADK? Well, to simply put, Google ADK is an open source, code-first Python toolkit for building, evaluating, and deploying sophisticated AI agents with flexibility and control. Unlike other agentic frameworks like LangGraph, CrewAI, LangChain, and so on, ADK gives you fine-grained control when building advanced AI agents that are tightly integrated with services in Google Cloud. So in simple words, it allows us to define agent behavior, orchestration, and tools used directly in code, enabling robust debugging, versioning, and deployment anywhere. So what makes it different to, well, other agentic frameworks? Well, Google ADK stands out here in several key ways. Number one, Google Cloud is native. Unlike LangChain, CrewAI, Autogen, the list goes on, ADK is specifically designed for tight integration with Google Cloud services, specifically Vertex AI, Cloud Run, etc. Number two, code-first approach. While LangGraph focuses on graph-based workflow and CrewAI emphasizes role-based agent, ADK prioritizes this: direct Python code and agentic behavior and orchestration. Number three, deployment ready. ADK includes built-in deployment capabilities to Google Cloud, like I said before, and this is quite beneficial because others require additional infrastructure setup. And number four, it's simpler architecture. Compared to LangChain's complex chains and Autogen's multi-agent conversations, ADK offers a cleaner, more straightforward approach to building agents. Now, if you've noticed, I've said agents quite a lot of times, but what exactly even is an agent? Well, this is a beautiful diagram by Google themselves in the documentation. As you can see, I took the image from Google, but it's quite a good image because it clearly shows what type of agents Google ADK provides. So, if we look closely, we can see there are three main types of agents: LLM-based, workflow agent, and custom logic. All of these agents inherit from this one base agent class, and you can see in the diagram there are arrows pointing from the base agent saying extended by. Now, what do agents have in common? Some agents have looping functionalities, some could have reasoning abilities, some can execute tasks alongside other agents, and some have access to tools. But the most important thing here to note is that these agents extend the base agent class, like I just mentioned. Like I said, there are three subcategories. Now I want to go a bit in depth about each of these, slightly, but it will make more sense once we get into the code. Number one, LLM-based agents. You can write these as LLM agent or agent in the code, and these essentially use LLMs as the base model for natural language understanding and reasoning. Number two, the workflow agent as defined here. Workflow agents include things like sequential agent, parallel agent, loop agents, the list goes on. But these really are controlled execution flow of other agents in predefined patterns. And number three, custom agents. Now, what if these two agent types don't really help us? And number three, custom agents. Now, what if these two type of agents don't really satisfy our needs? And that's where custom agents, aka this section with custom logic, comes in. We can build by extending base agent for unique, more tailored implementations specific to us. Now, if you want more documentation and details about these, you can go into these links I provided in the documentation. All of this code, remember, will be provided on GitHub. Now, we've covered a little bit of theory already. So how do we even get started? Well, here's the steps. Number one, you need to go to Google Cloud Console and create a new project. The window will look something like this. You can see that I've created a new project here called ADK DataCamp Crash Course and just simply create. It should look something like this window. So you can see that this is my Google Cloud Console and I've selected the ADK DataCamp Crash Course. Here is my user profile and here's the rest of the details. Then number 2. You have to select this project in our console. Most likely when you're first getting started, you wouldn't have selected this project. So it is vital that you go into the notifications part and you select this project. To confirm that you are working on this project, it should say you are working in and the name of your project. In my case, ADK DataCamp Crash Course. Number 3, head over to Google AI Studio. It should look something like this. And then you have to go and create an API key. So to do that, you need to go to this screen. This is my Google AI Studio page. You can see I've already signed into my account and I have to get the API key here and create an API key. And then I have to type in my Google Cloud project. Now, this is a very important step. Make sure to select the right Google Cloud project. Otherwise, well, you wouldn't be able to use this. Once you've created your API key and you've saved it in your project, you need to save this in your .env file as stated in step 5. Now, don't worry, this API key, although mine is shown, I will delete this after the tutorial because otherwise I'll go bankrupt. The next step, once you've done all of that, is you have to clone this GitHub repository. And lastly, you need to pip install the requirements.txt file. Once you've done that and you are successful, you're all set to go. And I'll see you in the next section where we build our very first agent. All right, people. So welcome to the very first agent we will be building. And I like to call it the welcome agent. This is the first agent we'll be building. And to get started, I want to go with a little bit of theory, but this will be brief, I promise. So the most important thing in Google ADK, especially when you're using something called ADK Web and ADK CLI, we'll be covering this in just a bit, is the folder structure. Now you can see in this README file which I've written here, you can see that this is quite important, and this is a lot more important in Google ADK than compared to other agentic frameworks. So the following folder structure you have to preserve at all costs. So this folder structure helps you set up the basic organization for your agent project. It creates a folder named multi-tool agent, as you can see here, and adds 3 files inside it: the init.py, the agent.py, and the .env. I want to take just a few seconds defining what each of these files do. Number 2, agent.py. This is where our main logic and the code for our agent will be. And number 3 is the .env file. And again, this is a hidden file for storing environment variables such as API keys or configuration settings that your agent might need. Now, make sure to have this structure because this is essential. Otherwise, well, it won't work. And this will also make it easier to maintain and build our agents. Now, I just want to quickly show you what the .env file should look like. So this is how the env file should look like. For the first 3 agents, you only need 2 keys here. Number 1, you need to specify Google Gen AI use Vertex AI is false. The reason this is false is 1, this is beyond the scope of this video. And if you're a little bit interested, number 2, Vertex AI is really used to deploy stuff to the cloud, which is slightly beyond the scope of this video. And then you need to have your Google API key, which you got from the Google AI Studio at the introduction of this tutorial. Perfect. So now that we've covered that, we'll now jump into the code and talk about it a little bit more. Okay, so this is the welcome agents Python file. Now you can see that I've imported 2 main things. Number 1, from google.adk.agents, import agent. And number 2, from google.genai, import types. Now I'll be talking about this one in just a second, but for starters, this. Now, one more thing to note, you should have no errors when defining these variables. If you have set everything up correctly in the introduction, this should work flawlessly. If you haven't, make sure to pip install the requirements.txt file. That is a common mistake, and I certainly have made that mistake quite a lot of times. So, back into this first line. Remember when I said there are 3 types of agents? Well, there is the base class, which is agent itself. Now, because we're using an LLM under the hood, we could have written LLM agent here or agent. You can see even in the hint, it says agent is equal to LLM agent. So if I write LLM agent here or just agent, it doesn't really matter. The code will still work regardless. Every time we define an agent in Google ADK, and we are going to be using ADK Web and ADK CLI, there are a lot of things you need to keep in mind. Number one, the name of the agent. In this case, I've kept this as welcome agent, and you can see in the comment it says name of our AI agent. This is also important to define each agent's identity. Number two is the model itself. If it's an LLM-based agent or agent in general, you will have an LLM as the baseline model. In this case, because of the Gemini API we copied, we're going to be using Gemini 2.0 Flash. Now, don't worry, this is completely free because all of this code will run in the free tier. You should have also noticed when you were in the introduction section that it didn't really ask for your credit card or any bank details. So don't worry, it won't cost you a thing, okay? Number three, a description. So this is like stated in the parameter, it's a brief description of the agent. And we're just going to say it's a simple greeting agent. And number four, the instruction. Now, this is one of the more important parts. This parameter, you have to clearly define what the agent's actions are. So, detailed thing the agent has to do. These are really the four main things you need to look out for. But there are some more things you can change. And that's where this line comes in. You can see that in the comments I've written for further configuration controls. Now, what exactly does that mean? Well, if you're building slightly more complicated AI agents, you might want to have more control over the agent itself. And if you've used OpenAI models before or come from any other agentic framework, you might have seen, for example, the top P parameter, the top K parameter, temperature, etc. And you can do something similar in Google ADK as well. So if I press this hint here, you will see that it says the additional content generation configurations. So for example, I have created two main parameters here, temperature and max output tokens. Now, max output tokens is kind of obvious what it will be. The agent can only output at a max of 250 tokens. If you don't know what tokens are, don't worry. Think of them as a subword, for example. And temperature, I've set to 0.2. Now, temperature is something which defines the creativity of the agent's output. So the closer you are to 0, the more deterministic output it will be. And the final thing which I need you to understand is that when you're using Google ADK, especially the CLI and the web version, you have to define a root agent. Now, you will see why in just a second, but you might be confused here. What even is Google ADK CLI and Google ADK web? Well, that's what we're about to do now. If I quickly activate my virtual environment, like such. Okay, so if I type in ADK, you should see something like this. This is a clear indication that everything you've installed is correct. Now, you can see there's a little bit of information as to what ADK is. There is API server, create, and so on. The two main things we'll be looking at in this tutorial will be run and web. So let's get started with running it in the command line interface or in your terminal. So how do you run this in your terminal or your command line interface? Well, you write the ADK, run, and then you need to specify something, and that is the name of the folder. So the name of the folder here was welcome agent. So I need to type welcome agent. And if I run that, you can see that I get this screen. Now it's saying user is equal to this. So now it's prompting me to enter something. So let's say hi. And as you can see, welcome agent has specified hello there. How can I help you today? Now, please note that we didn't specifically ask this conversation history like this user welcome agent. We didn't specify that anywhere in this code. Google ADK internally did that. So that's quite awesome. Now, if you want to confirm this is Google ADK itself, let me just abort it and clear this. And let me specify something fun like talk to me in a pirate manner. Perfect. Now again, I'm putting this in the instruction because this is how the agent should speak or a particular action it should perform. So if I run this code again and I ask it, who made you? And I press enter, you can see that the reply is in, pirate language. Ahoy there, matey, go on, so on, so on, so on. And you can also see it's specified Google, meaning this is Gemini model we are using. So remember one thing which I said earlier about root agent? Well, I want to prove that root agent, the name itself is quite important. So if I clear this and I change this to something like Bob agent, something completely random, and I go back to this screen and I type in ADK run welcome agent. Remember, it's not the name of this agent, it's the name of the folder. And I press enter. You can see that I've got an error and it says module welcome agent.agent has no attribute root agent. So this clearly specifies that we need a root agent. So if I write root agent here, clear this and run this again, this will work once more. So let's try that. Hi, how are you doing? Ahoy there matey, and so on and so on. Perfect. Now, what was the second thing I said? ADK Web. Now, ADK Web is quite awesome. So if I type in ADK Web, and this time I don't need to specify any particular agent, and I press enter, we'll see that this appears. Now I have to go onto HTTP localhost 8000, and I press it, and we get to this screen. Now this screen is quite awesome. So you can select your agents. In your case, if you're coding this from complete scratch, you won't see anything like this. This is just my virtual environment, but all of these are agents we'll be covering, so don't worry. Now, what was the agent's the folder's name we were working on? That was the welcome agent. So we select welcome agent, and wow, this was automatically created. Now we can enable token streaming or on and off, but we'll keep it on because it's better. And you will see there's a lot of stuff to take in. There's events, state, artifacts, sessions, eval, session ID. What is going on? Don't worry. Throughout this tutorial, it will make more sense. But for now, I want to keep a conversation going. So again, I'll say, hi, how are you? And try to guess what it will say. Well, something similar what it will say. Of course, you can't guess what it's actually going to say properly. But again, the key answer I wanted was the pirate theme, because remember, we didn't change the instruction at all. So this is the same underlying model as we ran in the command line interface. Now, I know I'm going a bit slow, but this is important. It's important to note what your base model is, what's going on with the agent flow, because when we go on to build more complicated agent, things tend to get messy. So that's why we're going step by step. Now, if you look on the left-hand side, there's events, state, artifacts, sessions, and eval. Now, artifacts and eval are beyond the scope of this video, but events, you can see that as soon as this came up with an answer, this was created. So let's take a look at what this is. If we select this, we can see that we can have a welcome agent, and it has the respective parts, aka the output. And you can see this was the role by the model, aka the underlying agent, welcome agent. The thing I love most about this ADK web is its clean interface, and I hope you like it more and more as the tutorial goes on, because it becomes especially helpful when you have more than one agent running. Now, if we go into the request part, this was what the instructions are. Remember, I wrote you're a helpful assistant that greets the user, talk to me in a pirate manner. This was the instruction by me, but Google ADK internally gives us this message as well, adds this to the instruction. You're an agent, your internal name is welcome agent, and so on and so on. And you can see that the contents was, hi, how are you, role user, and this was the request. So all of this makes up the request. So the underlying model, the system instruction, the temperature, max output tokens, my actual request, and my role are all the request in this Google ADK framework. And the response, well, you guessed it, it will be this. As you can see, ahoy there matey, that's the response, and the role was model. And this was an event. Now, I want to talk a bit more about this. So let's go back into the theory. Perfect. So we covered until this point, but we just went through ADK Run and ADK Web. So let's just quickly look into that a bit more. So ADK Run, like you just saw, was the primary command line tool to run our agents locally. It instantly launches our agent for direct interaction in our terminal. And we created the pirate mode where we were able to have the agent speak in a pirate themed language. Now, ADK Web, on the other hand, spinned up a web interface for our agent. It lets us chat with our agent in a modern web browser UI. The web browser UI, the underlying API which we're using is Flask. The modern web browser UI is provided by the underlying API, Flask API. And it's really great for demos, sharing, or a more visual experience. Now, I'm going to go back to the ADK Web section, and I'm back here. And now I'm going to ask it, tell me a joke. Now, there's a reason I'm doing this. There we go, some rubbish joke. But now I'm going to ask it, what did I just ask you? and if this runs, Shiver Me Timbers, you just asked this, whatever, a joke to tickle your funny bone. So in a pirate theme language, it's clearly saying that I just asked it to tell a joke. Now there's two things I want you to notice here. Number one, I never created any conversational history. That means Google ADK has inbuilt conversational memory, which is quite awesome because in other frameworks, I need to specifically build this, especially in LangGraph if you come from a LangGraph base. Number two, notice how every time I send a request, it creates an event here. So this was the treasure joke here. And if I go to event 3, it was Shiver Me Timbers, what did I just ask you? This part. So you can go through and flip through all of these events. And again, it's highlighted green, the welcome agent, because, well, this is the underlying agent we're using. And if you go into the request and response, you can see it also changes based on what the request and response were respectively. So have a play at this. It's quite cool. But going back to the theory, you can see that I've created an inbuilt conversational memory. And like I said, the agent automatically remembers the previous messages in the section, provides context to the AI, making conversations more coherent and context aware, and no extra setup needed, like I mentioned. But there are two things which we haven't really discussed in depth, and this will become more clearer as we go into the tutorial. But just to really get them started, session is a series of messages exchanged between the user and the AI agent, and each session maintains its own conversational context. An event are activities or actions that have occurred during a session, so they're useful for tracking, logging, or triggering specific behaviors. So that, my friends, was the first agent, the welcome agent. We're now going into our second agent. So our second agent will contain something known as tools. Now, again, if you come from an agentic framework background, you know how important tools are. But if you don't, let's quickly define what a tool is. So a tool is a modular component that extends an AI agent's capabilities beyond just simple text generation. So tools enable agents to perform specific actions, interact with external systems, and process real-world data dynamically. For example, it could check the weather, search the web, do math calculations, booking a flight, etc. Now, one thing to note here is that the LLM coupled with a tool, that's what really makes an agent. That is a very, very basic, naive definition, but you can think of an agent as that way. If I gave my LLM a task to check the weather, well, it wouldn't be able to do it. It will probably hallucinate and get it completely wrong because it doesn't have the real world data update. So what are the characteristics of tools? Number one, it has to be action-orientated. Tools execute predefined tasks such as retrieving data, like the weather report, stock prices I just mentioned. Number two, it extends the agent's functionality. Agents leverage tools to overcome limitations of static training data by accessing live information. Again, going back to the weather tool I just gave, it would have no idea what the current weather is without the tool because it would just hallucinate. And number three, and this is quite important, the deterministic execution. Tools follow strict logic defined by us developers, unlike the agent's LLM, which handles reasoning. Now, this doesn't mean you can't have LLMs baked into tools. Of course you can, but tools should give a more deterministic output. So what are the benefits of using tools in the first place? Well, real-time data access, task automation, and scalability. Now, there are different types of tools here, and if you want a full, comprehensive, detailed list, you can go into the official ADK tool documentation, but there are three main tools to look out for. Function tools, these are custom tools defined by us developers. Built-in tools, which are predefined tools for common tasks, such as web search, code execution. Now, these are tools which are provided by Google themselves, which we can use in our code. So these are plug-and-play tools. And number three, third-party tools. These are integrations with external services, such as Slack. Now, that was a lot of theory, so let's go into the code. Again, you can see that I've defined the tool agent folder as the file structure, the folder structure I mentioned in the introduction. This is very, very important, especially if you're using ADK CLI and ADK Web. Okay, so this is the code, and right off the bat, you can see I've imported the same line again. Now, forget this comment for now. This is a custom tool we'll get into shortly, but if we go down here, you can see that I've imported Google Search. Now, just before in the theory, I mentioned Google Search was an inbuilt tool, so we can really just use this and well, plug and play within. So just to quickly go over all of the root agent's parameters again, we have the name, basic search agent, the same underlying model, what this agent can do, a description of it, and in the instruction, I can answer your questions by searching the internet, just ask me anything. And again, Google Search is a pre-built tool which allows the agent to perform Google searches. And this is a new parameter, tools is equal to Google Search. And Google Search, you can see, is the exact tool we just imported. So now let's run ADK Web again by closing. Oh, we don't need to close this actually. Let's go to ADK Web. Now I can create a new session here. New session. You can see all the events, the state, artifacts, everything is cleared. And these are the two sessions. If I want to go back to the previous session, I can just go back like this. Now, going back to here, we need to select the tool agent, which is this. So let's say, hi, who are you? I'm an agent designed to answer your questions using Google Search. My internal name is Basic Search Agent, the exact name we just gave it. So let's ask it something like, tell me the current stock price of Apple. A cliche example, I know, but you can see what's going to happen. As of July 13, 2025, which is today's date. And again, the LLM, if it was just the LLM without a tool, it would have no clue what the current date is and the current stock price. And you can see it's the $211.16. So this is obviously right. But the thing to note here is if I go into the event, which is this, you can see that the event, the agent has changed. It's basic search agent and Google search. Now, I can scroll through the events here. So this was the initial message, hi, who are you? And then this was for tell me the current stock price of Apple. You can see the events are chronological. Now, there is one caveat here. Remember, Google ADK is still developing. So if you're selected a tool, this should ideally go green, but sometimes it doesn't. Google Search, this inbuilt tool especially, sometimes doesn't go green. If it goes green, it means that it is using that agent or tool, just for your reference. But this is still correct, and I'll prove this to you why this is correct. If I go back to the code and I don't give it this tool, and I press save, and I go back to ADK Web, and I refresh, and I clear the screen and I press ADK Web, and I select tool agent again, I can now ask it, what is the current stock price of Apple? Same question, but take a look at this. You can see that instead of giving me the actual output, it gave me Python code. And you can see that I don't have any tool provided here. So that's why under the hood, although it didn't go green here, the Google search, if I don't provide a Google search, it doesn't know how to execute it properly. So that's one thing to note. Going back to the code here now, I'm going to comment this bit out. And I'm going to uncomment this out. Okay, so now this is a custom tool I've created, get contact. Now, there are a lot of things to note here, so let's go through one by one. This is the parameter. It must take a person's name, and it has to be in the format of a string, and it should output the answer or the return, whatever, as a dictionary. And you can see specifying the return type. Now, here's the most important part when it comes to custom tools, the docstring. And the docstring is what the agent determines what the function does. So in this case, the getContact tool gets the contact details of the chosen person. Its arguments are person, which is a string, and that's the name of the person whose contact you want, and it returns a dictionary. Now, this is the industry standard of creating docstrings. You will see this quite often in all of documentation and tutorials. So it's good practice to start writing your docstrings as this. And lastly, we have to return it. So it has to be return contact, person's number is 12345. I've hard-coded the number here. I could have also specified another parameter, but we're keeping things simple. Now, you can see that the description has changed, tool agent, and this is tool custom agent. So the name has changed, but it's still under the same file. I've commented the rest out. And the tool I've specified is get contact. So now if I refresh ADK Web, and now I type in, hi, what is your name? You can see that it says I'm a tool agent, which was the name we gave it. Now we can ask it something like, could you tell me what Tom's number is, please? So now hopefully it should use the custom tool. And there you go. It used the get contact tool, and Tom's number is 12345. I mean, everyone's number is 12345, but you get the point. Now here's the cool part. If I go into events, which is here, starting with the first event. So this was event number 1. What was your name? And it gave us, I'm a tool agent. Again, it's green here because that's all I used. It didn't use a tool here. If I go to the second event, you can see that after I asked it what Tom's number is, please, it did use get contact, the tool which we defined earlier. And we can scroll to event 3. You can see how the arrow is changing as well. So this was from agent to tool, and this was from the tool's response back to the agent. And the event 4, which was the output, where it doesn't need the tool anymore, it gives us the final answer, which was Tom's number is 12345. And that's what we saw here, and that's what we saw in the web. So this is why ADK Web is quite awesome, because, well, when it is working, it clearly gives us a visualization of what is going under the hood. Super, super awesome and super easy to get up and running. And that, people, was the second agent we've built. So we've already built 2 agents, so well done. We're now going to be moving into a third agent, something known as structured outputs. So structured outputs, what are they? Well, normally a language model might reply with text like, John's number is 12345. But what if we want something more cleaner, like name John, contact 12345? It's more cleaner, more structured. Structured is the key word here. Now, there are many reasons why we would want this, such as it being used in code and making it more readable and structured. We might need to save it in a database. We might need to pass it between agents. So Google ADK lets us force the agent to reply in this clean format using something known as output schema. Now, there are 2 types of schemas in most agentic frameworks and also in Google ADK, the input and the output schema. So the input schema is what the user, aka me, must send. So it should be a particular format. And number 2, the output schema. This forces the agent to output in a particular structure. It could be something like this, for example. Now, we define these using Pydantic models. Now, if you don't know what Pydantic is, that is completely fine. It doesn't matter. Just think of Pydantic as a library under the hood, which allows us to build these schematics. If you want to see a tutorial about Pydantic, leave a comment down below. So you can see from Pydantic, import base model field, and the input format should be like this, and the output format should be like this. Now, we'll talk a bit more about this Pydantic code in the code. So I'll see you there. Okay, so this is the code for our third agent, and we're going to be mainly specifying about output schema because that's what's really commonly used. So here, the new line which we've imported and what we just saw in the introduction of this section was this Pydantic line. And again, it's a library to define the schematics. So to define the output structure, we have to have the class inheriting the base model. You don't really need to know what it is. The main line which you do need to know is this, greeting :string. So this means that the structured output must have a greeting which is under a string, and this is a type field and it will have a description. Each of these parameters will have a short description which will tell the LLM what it's about. So this is just a simple greeting message to the person. So the root agent has been defined like normally. There is no such tool needed here, but there are 2 new parameters, output schema, which is greeting output, and this makes sure that this is outputted as a structured output, which is defined by this Pydantic structure, and the output key, final greeting. We'll talk more about this parameter in just a bit, but if you look at the instruction, it says give a person's name, respond with a JSON output like this. Now, it's really sometimes helpful to also give in the instruction some more information about how we want these output to be. Yes, we've got the structured output, but this sometimes really helps it and completely enforces the LLM to output it in this way. So that's just a helpful tip. Now, if I go and run ADK Web again using ADK Web, and I select the structured output agent here and allow token streaming, we can say something like, hey, nice to meet you, Tom. And if we press enter, it should give us in the structured output like we wanted, greeting, hello, Tom. Now, there's nowhere I wrote hello Tom. It automatically gave it like the structured output like we wanted. Now, this was obviously a simple example, but hopefully you can see how important structured outputs are, especially when we're saving it to a database or saving the result and passing it to another agent or a tool. So structured outputs are quite important. If we go into the event, we can see that this is exactly what we wanted. And there is no such tool here because, well, the structured output or the Pydantic base class we created, that's not a tool, it's a schematic. So that's completely different from a tool. But if I go back to the code now, remember I mentioned this line, output key is equal to final greeting. Well, what was this about? If I go back to the ADK web folder, the ADK web file, and I go into state, you can see that I've saved this in the state. Now we'll be talking what state is in just a bit, but that is how you can save things into a state, making your agent stateful. Now we will cover state in slightly more depth in just a second, but that's really it for this section. Short, brief section, but hopefully you've understood how important structured outputs are. Now I'll see you in the fourth section. Now this will be a very simple agent, but with slightly different perspective. We're going to be using other LLM providers, specifically OpenAI. Now you can use whatever LLM provider you want. If you go onto the documentation here, you can find a list of models you can use. The most common models I've seen when developers are developing using Google ADK, although remember this is still quite new, is really OpenAI and Anthropic models. I'll be going for the OpenAI model here, but you can also go for Anthropic as well. Okay, so to do this, if you had installed the requirements.txt file, you should not need to do this. But if you didn't, you just need to pip install Lite LLM, which is just a module in Google ADK, which allows us to talk to other LLM providers. If you want to get access to OpenAI, you need to create an OpenAI API key. And to do this, you need to go into the OpenAI platform and create a new secret key. Now, this will cost you money. I think the minimum amount is $5. But if you don't want to, you can just simply watch this video and keep this in the back of your mind. But this will be quite quick. So if we go to the code now, which is this, the only new thing which I've added is this line. From Google ADK models.LiteLLM, import LiteLLM. Now, one thing to note is the OpenAI API key or the Anthropic API key must go into your env file as well. I'm not going to show you the env file, otherwise my API key will be exposed, and again, I will go bankrupt. Now, defining the LiteLLM models, you have to structure it like this. So you write LiteLLM, and then the model. So your model name provider, in this case, OpenAI, and the name of the model, GPT-4o Mini. You can't simply write GPT-4o Mini or GPT-4o. It wouldn't work. It'll throw you an error. Similarly, if you were using Claude, it would be Anthropic/Claude 3.5 Sonnet, for example. Now, the root agent is, again, quite simple. We're going to, again, talk like a pirate, and we will generate a social media post about it. We're going to keep it concise, relevant, and easy to understand. Actually, if it's easy to understand, we shouldn't be talking to like a pirate. But the main thing here is now we've specified the model to be a Lite LLM model. So this time, let's run it in our command line. So we can do ADK run and the name of the folder. In this case, the name of the folder is OpenAI agent. So OpenAI agent, and I press enter. And now we can talk to our OpenAI model. So we can say, hi, who made you? Let's say, who made you? And you can see the Lite agent is using GPT-4o Mini, provider OpenAI. And it says, hi there, I was created by a team of researchers at OpenAI. Now, this obviously shows that it's not Google because Google wouldn't say this, right? But this was a very short subsection to really show you that you can use other models as well. So yeah, that was the end, and I'll see you in the next section. Okay, so now we're getting into slightly more complicated territory, and we're going to start this off with sequential agents. Now, this will be the very first time we get to build multiple agents in one go. So what are sequential agents? Well, they're agents that work in a chain one after another. So how do they work? Well, each agent passes its output to the next agent. And why do we use them? Well, break complex tasks into simple, more manageable steps. Each of these simpler, more manageable steps will be completed by one agent respectively. So an example we'll be coding up is the recipe. So we'll have 3 agents. One will be the research agent, which finds ingredients and the methods, and we will give it the Google search tool. Number 2 will be the creator agent, which writes the recipe. And number 3 will be the enhancement agent, which adds tips and variations to this. So it'll be quite a cool agentic system we're about to build. So the result should be a really detailed, sophisticated output than what a single agent would have completed in one trial. So this is a diagram which I created. And you can see that there are 3 agents, agent 1, 2, and 3. And it's not necessary that the agents have the same tools. They could have different tools. They might not need a tool. So this diagram hopefully tells you that the number of tools is unique to each and every agent. It doesn't influence the other agent's output, unless if there's an error, obviously. But TLDR, you can think of this as a chain of agents. So let's now go into the code. It looks like there's a lot of code here, but in reality, it's just the instructions inflating the amount of code lines there are. So don't panic here. So like I just mentioned, we need to create a recipe research agent, which finds ingredients and the cooking methods. So we've given it the name, the tool Google search, because remember, it should be able to access the internet to get us some good recipes. And this is just an instruction, culinary researcher, etc. You get the point. And the output key, we want to save it to our state as recipe research. The second agent we want to create is the recipe creator agent, which actually creates the recipe itself. Now, again, this will use the same model as we have before, the same underlying LLM. And we've given it a name and its respective instructions, description, and the output key, aka state parameter it's going to save as. And the third agent which we wanted to create was a recipe enhancement agent, again using the same LLM as the background model and these instructions and everything. But you can see that we have now given it a context variable, this thing in yellow and curly brackets. We'll talk more about context variables in just a second, but for reference, you can think of context variables as like an input which needs to be passed to this agent's instructions. And this will obviously come from the previous agent. And the previous agent was a recipe creator agent. So to create a sequential agent system, you need to use the sequential agent part, and I've named it recipe development system and a simple system that researches, creates, and enhances recipes, a short description. You don't need to provide an instruction here, it's completely fine, but this parameter is sub-agents. Remember how we created tools? Well, sub-agents kind of work like that. You need to specify all the sub-agents you have in order. So recipe research agent, recipe creator agent, recipe enhancement agent in sequence. Now let's run this in ADK web. So I'll quickly write ADK web here, and I'll again press token streaming and go into sequential agent. Okay, now let's say, hi, I want to create a recipe regarding chicken, pasta, sauce. You can tell I'm a professional chef, and some other ingredients. Recommend me something. All right, let's see what the agent says. So here's a breakdown of popular chicken pasta recipes, and you can see the chicken preparation and everything, which is happening. That's event 1. And event 2, okay, based on the research for creamy Tuscan chicken pasta. And number 3, this is the final recipe. So as soon as this output finishes, we will talk about this in slightly more depth. Wow, that's a lot. And that's the end of the request. Okay, let's go back here. This is the first output, and the first output was provided by our first agent. If we go into the event 0, or the first event, and press it, you can see that we have the recipe development system, and we have the 3 agents, recipe research agent, recipe creator agent, and recipe enhancement agent. And you can also see that the recipe research agent has the Google search tool with it. And because this is green, we use the Google search tool to come up with a recipe or to find a recipe. And the recipe it found, based on all of the parameters and ingredients I told it to, it came up with creamy Tuscan chicken pasta. Now we go into the second agent, which was this response. So this was the first response, and now this is the second response. And you can also see, okay, based on the research, which was provided by the research agent. Now, if I press the next agent, you can see that it's gone green here. It doesn't have any tool because we didn't give it access to any tools. And this was its output, which is the exact same as here. You can see, okay, based on the research, here's a recipe, and it's the same thing as we can see here. And again, if we go into the third one, we can go into event 3, and this is highlighted as green, meaning that this is the agent which is running here. And this gives us the final thing with cooking tips and variations as well, and some more suggestions as well. So last thing which I want to show you in this example is the state. And you can see that every time an agent completed its task, I also told it to save it as a state. So the recipe researcher's final answer was here. The final recipe is here as well. So the research and the final recipe is all being recorded in the state. And this allows us to create stateful agents, and we can use this in further conversations. And this state will come especially useful when we use in-memory service and persistent storage. These two terms we will be going into shortly, but just remember, we have now saved this as state. You should now know how sequential agents work, how they look like, how they visualize. You should also find that it's really simple to create these sequential agents in Google ADK. I mean, if we go back to the code and I close this, you can see that all I had to do was define the agents like this and just write the sub agents, and well, we created a sequential agent. Now, what's the opposite of a sequential agent? Well, the opposite of a sequence, well, it's parallel. So is there a way we can run these agents parallelly or at the same time? Well, that's what we will be exploring in the next section. Okay, so now let's talk about parallel agents. What exactly are they? Well, simply put, they're agents that work simultaneously all at the same time. So how do they work? They run in parallel, hence the name. But the crucial thing to note is that they complete their tasks independently. But why do we use them? Well, that's also quite obvious. It speeds up complicated tasks by doing multiple things at once. So the example we'll be coding in this time will be a travel planning system, and it will contain 3 agents. Number 1, it will contain a hotel agent, which will search for accommodation options, the restaurant agent, which will find dining experiences, and the activities agent, which discovers things to do. The result should be hopefully a system which produces faster completion and more comprehensive results from multiple sources. Now, TLDR, if you want to skip, it's just think of them as agents working side by side. And I created a diagram here to hopefully illustrate that. You have your first agent, or it could be an input query by the user, and you have your parallel agents working at the same time independently. And they can have 1 tool, 2 tools, no tools. It doesn't matter. They're completing tasks independently, meaning that tool allocation or the number of tools they each have is independent. All right, so I'll see you in the code. Okay, so here's the code. Honestly, once we go through it, you will see that it's largely the same as the sequential agent, which we covered in the last section. The only key difference here is this keyword, which is a parallel agent. We swapped it out for the sequential agent keyword. But you will see that there's these 2 lines, import OS and this OpenTelemetry package. The reason I've included this here is because I was personally having quite some trouble running this on ADK Web. It runs completely fine on ADK CLI. It also runs fine on ADK Web, except the interface part where it shows which agent is running at once. That is a bit buggy. So I did some research. It's to do with something called OpenTelemetry. It's not really to do with Google ADK. It's the internal Asyncio package. So even if you run this in CLI, you don't need to use it. I just wrote it here because some of you might use this on ADK Web and it might not work. So that's why I've included this here. Remember, Google ADK is still a library which is under development and its updates are happening daily. So be cautious about that. But let's continue with the code now. So remember, I mentioned that there will be 3 agents. The first agent is a hotel search agent, which has a name, the model, and the tools. Each of these agents will have 1 tool, which is Google search. The description is as follows, and you can see the instruction as well. The output key, I want to save it in the state hotel options. Similarly, the restaurant agent is quite similar as well. Almost exactly the same, it's just it's specific to restaurants. And again, the same thing with activities. Now, the main difference between the previous section's code is here. Rather than coding it as a sequential agent system, we've got it as a parallel agent system. And the sub-agents are these 3. We've got a short description of what's happening, what the system is supposed to do, and we've got the name of the system as travel planning system. Now, if you run this on ADK CLI or command line interface, I've already ran it for you to save some time. And Here you can see that I have written, hi, can you give me recommendations for your respective things for my trip to London? So I'm planning a trip to London. I want this travel planning system, which is this entire system of parallel agents, to be able to provide me with hotels, activities, and restaurants. So if you look closely, you can see that this is the restaurant search agent's response. So you can see here is a summary of dining recommendations for your trip to London. And notice how all of this is specific to restaurants. It's not conflicting with the hotel outputs or activity outputs, because all of these tasks run independently. Similarly, once that's done, then we have the hotel search agent, which also ran at the same time, and this was specific to hotels. And lastly, you can see that there is the activity search agent, which has produced some activities such as going to Buckingham Palace, some outdoor activities, and all of these agents use the Google search tool internally. So that was the final output. Now, this was quite simple, and really to build upon this, I have a little bit of a homework task for you. Okay, homework. So to really consolidate this, I want you to take our parallel agent system, which you can get on GitHub again, and then add another agent at the end of it so that it takes all of the three inputs and summarizes everything to the user. It should look something like this diagram which I've made. Now, why do I want a summary agent? Well, if you just saw, this was, well, a lot of information. And if you have more than 3 agents, for example, it could get quite overwhelming quite quickly. So your task is to create this sort of agentic system. The user will request something like I did about the London thing, which I requested here. Something similar to that, and then the 3 agents will run parallelly. They will all have their Google search internal tool, and all of their outputs will be then passed to the summary agent. So this is the agentic system you need to make as the homework. Once you've done that, I will see you in the next section. So in this section, we'll be talking about session agents. Now here's where we start moving towards memory. This is going to be quite complicated, and this is quite advanced as well. So it's fun, but be prepared. Ready? Here we go. So before we dive in, 2 quick notes. Number 1, sessions are quite important. We've mentioned sessions quite a lot of times already, but now we'll actually define it. And number 2, we won't always be using ADK Web and ADK Run and ADK CLI, especially not in production. So let's try to come up with a way which we can run our agents without having to use the ADK Web or ADK Run package. So let's define session. Honestly, you can think of a session as a conversational thread attached to a specific user. And a state, which is also something we've mentioned before, is a Python dictionary representing session memory or the bot's context. So at the create time, we initialize values the agent might need, and it includes temporary flags, user preferences, conversion steps, etc. All of these are things which the state might include. Here we talk about 3 more components, and I've tried to give it as a chef analogy, so hopefully it starts to make sense. Number 1 is the agent, and in this analogy you can think of it as the chef. The agent wraps our language model with a prompt template. So you can think of the chef who follows a recipe with blanks, example, username, favorite color, that gets filled in at runtime. Here, username and favorite color are context variables in our example code which we're about to see. And the crucial thing is the chef never forgets to read the recipe before cooking. So remember that point. Next thing which I want to talk about is the session service. And this is the notepad in our analogy. So it stores per user per session state, aka memory. So it acts like a notepad where you jot down each user's preference, counters, or other contexts which might be important. And before every response, the chef, aka the agent, it glances at the notepad to know what ingredients to use. The final thing which we need to talk about is the runner. And in this analogy, it's been represented as a waiter. So it orchestrates the entire flow when the user sends a message. It grabs the correct notepad, hands it, and the user's order to the chef, and then brings back the chef's answer. You can think of it as kind of like a messenger, and it ensures that the chef always works with the freshest information. Now, this might not mean much to you, but I promise you in the code, it will make a lot more sense. But visually speaking, a runner can honestly be viewed as this. It's really just a fusion of the session and the agent combined into one, and it passes the information between the chef and the notepad, aka the session service. Now, going back to the session service, this is the most crucial point. In Google ADK, there are 3 main types of session services. The first is in-memory session service. Now, this stores all session data directly in the application's memory, so it has no persistence. Now, what does persistence mean? Well, it means that data is lost as soon as the application is closed. So let's say if I'm having a conversation with my agent and I just close the application, it won't remember what I just talked about if I reload the application because it's non-persistent, the data is lost. So to combat that and to have persistent storage, there's two other methods. The Vertex AI session service, which uses Google Cloud's Vertex AI infrastructure, and we can communicate this via API calls, and this is used for session management and is persistent. So it's best for scalable production applications deployed on Google Cloud. Now, this is slightly out of scope for this tutorial, but the third one is what we'll be also using in the next section, and that is database session service. So that connects to a relational database, example, these databases, and they store session data persistently in tables. Now, it's best used for applications needing reliable, persistent storage that, crucially, you manage yourself. Now, the above information was all taken from this documentation. So if you want, you can click on this link and you can read more in depth about it. But I built this visualization to try to help clear some doubts about what a session service is, especially if this is your first time hearing about it. Imagine I am having a conversation with my agent. So this is me. I send it a message and it needed to use a tool and then it output it. Then I send another message and then it responded again, and so on and so on. This entire thing, this state plus this conversation, it counts as a session. Now you see this is the unique identifier for the session. How did I get this number or a string? I honestly just spam my keyboard, but that's not the important part. The important part here is the session consists of the state and the conversation. Now, events are things like the user message, tools, agent responses, and all of these user message, tools, and agent responses you see. I just didn't draw arrows to all of them because then the diagram would become cluttered. Similarly, you can see that another session has happened here. And again, what did we define a session as? If we scroll up, we said session is a conversational thread attached to a specific user, meaning that within our app, this could be one user, let's say person A, and then person B could be having a separate conversational thread, aka separate session with our agent. And all of this is encompassed by the session service, which are these three session services we have available. This is a little bit more description of how it works. We've already gone through it, but now let's jump into the code and see how this actually plays out. So now in this subsection, we're going to be using the in-memory session service. But let's quickly look at all the imports we've done. Number one, UUID. This is a library which is used to generate a unique session ID. Remember the string which you saw where I spanned my keyboard? That's what this library does for us. So the second line is from google.adk.sessions import this service. And again, in-memory service is something which stores the user data. It's one of the three session services we looked at. Then we already know what an agent is. We discussed what a runner is. These are the types, and this is our env. And we load our API keys here. Perfect. Now we define our agent, and I've called it chef to stay true to our analogy here. And I've called it information agent, and it's going to use Gemini as the underlying LLM. But why have I called it information agent? The main task of this agent is to have the instruction as the user's favorite color is this, their name is this, and their favorite subject is this. And then the agent has to answer questions about it. So it's quite a simple agent, but it proves why these session services are quite important. So again, this instruction, which you saw here, is a prompt template with placeholders, also known as context variables, filled using session state before each invocation. To actually instantiate the session service, we use this. In-memory session service is a session backend that stores conversational state in memory. So you saw the diagram which we just saw where we were having conversation with our agent. That's what this will store, but it's non-persistent. So as soon as we close out the application, it will just go and disappear. Now we generate the unique session ID, and we use that UUID library, which we imported the first line. Now we create the session. So we instantiated the service, but now we actually create the new session for this user. So the app name, we'll call it information app. We'll say the user ID is my name, Vaibhav, the session ID, which we got from this, and the state. And this state will be passed to the agent via our runner. and the agent will know, okay, this is the favorite color, this is the user's name, and this is the favorite subject. So the runner, aka which we have defined here, is the manager that coordinates between the chef and the notebook. Hopefully things are starting to make sense, but if it's not, it's fine. We'll proceed slower. Now we send a message, aka the user message, as you can see by here, role user. And we've asked it, what is my name and what color do I like? So based on this, it should really say the name is this and their favorite color is green. Okay. And now here is this piece of code for ev in waiter.run. This is what the waiter performs. So let's talk a bit more about this. So as soon as this for loop is executed, the runner basically retrieves the session by user ID and session ID. Now why? Because in this line, you can see here, waiter.run, user ID is passed, the session ID is passed, and the new message, which is this, is also passed. So that checks out. Then internally, the placeholders, aka these context variables, which you saw here, are filled out with the state which we've passed, which is these. Okay. And then the Gemini, which is our base LLM, which we define in the agent, that gets called, and then the final output is outputted, and we see the message. Once that's all executed, we now manually fetch that session from memory so we can inspect its state, and then we print the updated state. So let's take a look at how this works. To run this, I will just press the run button, and we've got our output. So you can see the final session state is correct. It's green, it's my name, and it's mathematics, which I passed. Where did I pass this again? You can see here, favorite color was green, this was my name, and my favorite subject is maths. Now, this piece of code here was executed based on here for event in waiter.run. So let's walk through this a bit, because this is going to be the part which might confuse you. So here you can see that there is the part here. Let me actually clear this up. 1 second. Clear and run again. You can see that the text is, your name is Vaibhav Mehra and you like the color green. But who came up with this? Well, that was the underlying Gemini model. As you can see, Gemini is called and we got our output. Now, why is there only a single iteration here? You can see that I printed this dash line to say when the final response is outputted. But realistically, there was only a single event which happened. Why? Because all I asked it to do was tell me what my name is and what my favorite color is. That still only counts as one event. But here we've printed the final response. And if that has content, which it does, which the content being this, we output that and we print it. And this line here is what you can see here. Your name is Vaibhav Mehra and you like the color green. Now for this final session state, it was printed through this for loop. There were three print statements. There were three key value pairs, which were favorite color, name, and favorite subject. And that's what's being printed here. So that's all well and good, but here's a problem. So let me clear this screen and let me go here. And let me change my user message. Now let's say, can you also change my favorite color to red? Okay, still quite a basic question, but watch what happens after I run this. You can see from the response that it says, however, I cannot change your preferences. I can only remember and use the information you provide. You're free to like whatever color you want. So quite an unhelpful response. And you can see that the final session state is still the exact same original sessions, the original state we had provided. So that's a problem. And we've learned something at least, which is that the model can't modify the state by itself. So we need a different way to be able to parse it. So how do we do that? Well, let's brainstorm and go to the drawing board. Things we can potentially do. One, we can manually update the state ourselves using something like this pseudocode which I've provided. But here's the problem. If we have many different context variables, we're going to have to do this for every single one of them. And this will be quite long and it will be prone to human errors. So the second option is we use the LLM, just the LLM, to return structured output, aka to return something which we can use and pass to something else, something like this. But there's a problem with this as well, that this could be problematic because the LLM outputs are stochastic and we would prefer something which is completely deterministic. So the third way is to use ADK tool calling or using tools. but this could be quite complicated to integrate. Wouldn't it be better if we had something simpler? So the final option is using structured outputs, where we can go for this since it's good practice and we're building on top of what we've learned in a previous section. To be honest, we'll be using quite a lot of this anyway. To be honest, we'll be using a little bit of each of them anyway. So you'll see what I mean in the code. So if we go to the code now, the code here is largely the same, except now we're using Pydantic again to be able to create our structured outputs. Remember, if you don't know about Pydantic, it's completely fine. You don't need to know Pydantic, but there will be a future tutorial on DataCamp on this channel, so you can watch that if you want to. But going forwards, we're creating the same agents, but this time with a better instruction, having some slight nudges to get what sort of output we want. And this is the output schema we've asked for. So the state output, which is a schematic using Pydantic. We're setting up the in-memory session service again, and we're providing the session ID. And now we create the session once more with the original state. We created the same runner. We've now changed the message which we want. We're going straight for please change my favorite color to red and please change my favorite subject to computer science. This model or this architecture should also be smart enough to know that it should not change the name or modify it at all. We run the agent and capture the raw outputs, and we grab the updated session, and let's just see what actually came out. So this was the output, and you can see that this is the final state, which is red, my name, and computer science. It's done what we wanted it to. The favorite color was red, the favorite subject was computer science, and the name has been completely preserved. So this is a way you can use structured outputs to be able to change your state. Now, there is one more way to change the state, and this is the proper way, and that's something called tool context, which we're about to cover in the next section. In the next section also, we'll be covering the persistent storage, which we've been discussing. So I'll see you there. So this is the final section for this tutorial, and it's quite a big one because everything will start hopefully clicking now. So persistent agents. What are they? Well, they are agents that remember our data and progress even after we close and reopen the app. We've already discussed this before. But what are we going to be coding in this section? Well, I've decided to build a habit tracking agent. When we start the app, it should be able to check if we already have a session. If we have already got a session, it should be able to load that session. Or if we have never created a session before, i.e. this is the first time the user is using the session, then it should be able to create it automatically for us. It should have three tools. It should be able to add habits, view habits, and delete habits. And all of these changes should be saved to a local database. That way our data is safe and persistent. So that's the goal. And the thing which I mentioned briefly in the end of last section was tool context. So tool context, it's a bit of an advanced topic. It's slightly beyond the scope of this video. I've chose to include it because I think you can understand it. But in the most simplest term possible, it's really just a way for giving our tools direct access to the current session state, so we can read and update the habits automatically. And we do this by using tool context.state. So you'll see that in the code. So TLDR, think of persistent agents as our personal memory keepers. They make sure our progress and preferences are always remembered. So let's go build this habit tracking agent. Right off the bat, you can see that we've imported the database session service. And this is instead of the in-memory session service, which we imported in the previous section. We now load our API keys, and these three constants are created. So this is the persistent storage file, aka where the database is located. This is the name of our app, which is Habit Tracker, and this is the user ID, which is me, and this will identify the user. We'll be modifying the user ID in just a bit as well. Now it comes to the tools. Now you don't need to understand the internal mechanics of these tools. That's not what this section is for. The reason this section was created was to help click things about sessions, events, runners, agent, all of that stuff. So just briefly looking at the tools, you will see that we've got our docstring and we've got tool context here. So what happens is that the tool context first retrieves the state, aka the habits. And at first, the habits is obviously going to be an empty list. It then appends the habit to this list, and then it prints, added habit, and it returns the action and the fact that we've added it. If this fails, aka if there's no tool context provided somehow, I've also written a short script which is where we manually update the session. That's only as a failsafe mechanism. If we go to the view habit, it's something similar. Rather than appending the habit, all we need to do is view the habit, and that can be simply done by just using get. And again, I've created a simple failsafe mechanism here as well, if tool context is not provided. And lastly, for deleting habits, we're going to be getting the habits and we're going to be popping, aka removing that habit from the state. And again, a failsafe mechanism here, which you don't really need to worry about. Here is where we've defined our agent. So I've got the name of the agent, the underlying model description, and what tools to use. And these are the list of tools it has access to. Perfect. Now we create this session state. So we've used the database session service and we've passed in the parameter of database URL, as you can see here. And this is the initial state. So the username, which is my name, and the habits is nothing because we don't have any habits to begin with, right? Now, here's the most important part of this code. This if statement here, it checks if we've already got a pre-existing session. If we have a pre-existing session before, aka the user has already got a conversational thread going on with the agent, then it loads that session ID using this. But if it doesn't, and this is the first time that user is talking with the agent, then we use this session ID, we create it. Then we create the runner, and this is just for debugging purposes, which I've put. Honestly, we can just comment it out. But if you want, if you do run this code, you can put it to keep track of the flow. Then we use this function to ask the agent. We run it for every single event, and we only print the final response because there will be 4 events which will happen per request. You'll see what I mean in just a second. And this is the main function where we keep on continuously ask the agent by this while loop. That was quite a lot. Yep, let's actually run this now. You will see that there should be a database appearing here soon. There it is, habit database. So let's really inspect it. So if we go here, you should see that in terms of events, there's no event. But in terms of session, there's already one session which is created, which is my name. Why? Because we already manually created the session here, which was over here, because we didn't have a session before. So it automatically created the session for us. Now let's actually ask some things for the agent to do. So say, hey, can you add the habit of me having to run 5K every day, for example? And these are the habits, and it says, hey, I've added the run 5K every day to your habits. So if we go into the database and check the sessions and check the state parameter, you will see that under my username, we have a new habit, run 5K every day. But in terms of events, now there's 4 events. But why is there 4 events for one single request? Well, for starters, this, if we go into the content part, you can see this was my request. Hey, can you add the habit of me running 5K every day? Then the second event was actually calling the tool. So in this case, we have used internal model has used add habit. You can see it's the model because the role is model. And the third event is the tool response. And it was add habit run 5K every day, showing that it was successful. And then the final was the event of the agent actually outputting back to us, which was, hey, I've added this habit to your habits. So that's why for every single request, there will be 4 events which will be happening. If we proceed, let's say if we want to create another habit, say, can you also add the habit of me learning Spanish every week? And it looks like it's also done that as well. If we check the database, you can see that the number of sessions, it's still 1 because I'm the only person who's used this app so far under this user ID. If I go into events, you will see that now there's 8 events because we've sent 2 requests. And if we go back to the session and look at the state, you will see that there are both of our habits now. Perfect. So this is working. The add habit tool at least is working. Now let's say I want to delete the run 5K every day habit. So I want to delete the run 5K every day habit. And you can see we've got this. To delete run 5K every day, which is habit number 1, say delete 1. Now, why did it ask this? Because in the code, I had mentioned it to give the index as well. So we can say delete run 5K every day, which is habit 1. And this should work now. Perfect. It does look like it. No problem. I've deleted habit 1. So if we go here, relaunch this database, you will see in terms of the state that that is gone. So we only are left with this. Now, if I close this now and clear everything, and now I'm going to change one thing, which is the user ID. So let's say the user ID is Bob, for example, and let's also change the name of this as well. Now, if I run this, what do you think will happen? This is the most important part of this whole tutorial. If you get this, then you've understood. So let's say I say, hey, can you add the habit of me cooking or something every day? Not much of a habit, I know, but it's still there for, oh, there we go. Hey Bob, I've added cooking every day to your habit list. Now, if we go to the database and look at the sessions, now here's the most crucial point. You can see there's two different sessions which have been created, my personal one and then Bob, who's another agent. So under the exact same app name, we've now two sessions, aka two conversational threads going on. If we look at the events, you can see all of the different events which were occurring. So if we look at the user ID, these are all the events which I did, and these are all the events which Bob did. And that is the end of this tutorial. I hope you learned a lot. It was quite intensive, especially nearer to the end, but with a little bit of practice and doing the homework exercises I provided, you should be able to master Google ADK soon. To summarize what we've learned, you can see all of the different agents we created here. And if you want to build yourself to another level, to a further level, then I highly recommend checking out the course down below on DataCamp. It will take you to an even more advanced level than we already are at. If you have any comments, feedback, criticism, or any questions in general, then feel free to comment them down in the comment section below. And I will see you in another tutorial. Bye for now.